right. We don't have anybody in person here today, so for those of you who are online, please speak up if you have any questions at all. Otherwise, I feel like I'm talking to an empty room, which I'll do my best, but we will see. This is the problem that I tossed in at the very end of the last time we did matrices, and so I figured it was a good place to start. Reminder that a matrix is a collection of pieces of information, usually numbers. They are composed of rows and columns. This particular one has 1 row and 3 columns. This has 3 rows and 1 column. And because those inner dimensions are the same, we are able to multiply them. And so 1 by 3, 3 by 1. This makes it possible, and this tells us how big our answer will be. We will have the matrix of size 1, 1, and they already give us that the answer is 18. But if we multiply this out, remember, we're going to be taking the first element times the first, second times second, third times third, and we get that 6x plus 3y plus 12z, bad z, is equal to 18. And they asked us in the original for 2x plus y plus 4z. And if we compare these two, 2 times 3 is 6, y times 3 is y, 3y, 4z times 3 is 12z. We can divide all of these by 3. This one also by 3. And we get 2x plus, no, not 3, sorry. 3 divided by 3 is just 1. 2x plus y plus 4z is equal to 6. And so the evaluate of 2x plus y plus 4z is equal to 6. Without knowing the individual values for x, y, and z, we can still find that number. So just going over sizes of matrix, element of matrix, multiplying matrices, and then the trick at the end. Does anybody have questions about matrices as far as that goes? Okay. I went through the practice tests hunting for matrix problems, and the two things that I found were there's not a lot of them. It averaged around 1 or none per test, but at the same time, if you say, oh, I don't have to do that, that'll be the time that they have 3. So the first one says, the student bookstore carries books for 3 courses, A, B, and C, offered at a local community college. Each course is offered in 2 semesters, X and Y. The matrices below show the number of books required for each course and the number of students enrolled in each course section. What is the minimum total of number of books the bookstore needs to have in stock to meet the demand for both semesters? So, with matrices, they frequently will have the labels outside as part of the setup, but the matrix itself is just the numbers that allows us to do this manipulation. And so it gives us the point And so just for your reference, if I asked how many students were enrolled in course B first semester would be the first row. Course B is the second column. There were 250 students in that class first semester. So the second matrix they give us are books for the semesters A, B, and C. And again, course A required 3 books, course B required 5 books, course C required 7 books. And so even more so than the dimensions matching for a standard can this be multiplied problem, here it's important that this A, B, and C is the same information as A, B, C. It's talking about the courses that was offered at this college. And so the question is asking for the total number of books the bookstore needs to order in order to have enough for every single participant in these classes. This will be what kind of problem? If you start thinking about it, well, first semester, if there's 120 students and course A needs 3 books, I'd be taking 3 times 120. And so that right there is going to tell us it's a multiplication problem. Our answer is going to be a multiplication matrix. This is 2 by 3. This is 3 by 1. The centers match, and so again the multiplication is possible. Our answer is going to be 2 by 1. And I'm going to make this rather large so I have a chance to write in, because there's going to be a lot of calculation. This one is going to be one that you will want a calculator on for speed. It's not hard, but the setup can be a little bit long. And so for the first row and the only column, because we only have one, we are taking 120 times 3 plus 250 times 5 plus 165 don't know what that was. So plus 165 times 7. And again, I do not have a calculator, so I'm going to rely on you guys to either give me an answer or I'm leaving it there. But for our second row, we're going to be taking our second row, again, times our only column. And so we'd have the 105 times 3 plus 269 times the 5 plus 135 times the 7. The problem asked for the total books in the entire year, and so that would just be a case of taking semester 1 plus semester 2 and adding them together. Again, not hard, little bit time consuming, and so make sure that you are set with the calculator for that one, because I don't want to do that longhand. Did it one year. The other matrixy one is in the practice mathematics practice test the blue book, but it's practice test number 4 on page 286 for me. But it gives, the table below shows the number of rows and columns in each of 5 matrices. And so really quickly, we have matrix R, S, T, U, and V. And we have number of rows and columns. And they're going purely theoretical on this one. They don't give us any true numbers. They just give it to us as variables. Rows is number of B, columns is C. This is B by B, which means it's square. We have A by C. We have B by A. And we have C by B. And they give us the combination V times U, V times, sorry, not U, V, U times T, T times V, R by V, and R times T. So, of these 5 options, which one is not possible? So, for VU, V is C by B, U is B by A, centers are the same, that is possible. U is B by A, T is A by C, centers are the same, that is possible. For T, we have A by C, V is C by B, possible. R is B by C, V is C by B, possible. Last one, we have B by C, and T is A by C. Even though they have the both C, because it's not in the middle, not possible. Because we've gone over matrices before, I really kind of need some direction from you guys on what you would like to see. And if I don't hear anything, I'm going to assume that means you would like me to move on. Again, And for matrices, because the multiplication can take so long, the one with the books was the longest one I've seen. Most of them are more conceptual about, can this be done? Remember that each element is listed by rows, then columns. The dimensions of the matrix tell us the rows and then the columns. In order to add or subtract matrices, they have to be the exact same size. The scalar multiplication of a matrix means that each element is multiplied by that number. And in order to multiply matrices themselves, they have to have those same inner dimensions, because we're going to multiply the corresponding parts. And if you have 3 pieces on this row and only 2 here, it doesn't work for that multiplication, which is why those inner dimensions have to be the same. And your final outside numbers tell you what the new size of the product or the result is going to be. And so if you have a product that is 2 by 3, your first element is going to come from the first row, first column of the 2 you're multiplying. The second element, first row, second column of the 2 you're multiplying. And that is matrices. So the other one that he wanted me to focus on is circles. So if you want to flip over to page 11 of the book, you can. So digging into Algebra 1, Algebra 2, you learned vertex form for a parabola that said y equals a times x minus h squared plus k, where h and k were the coordinates of a vertex, or that middle point in the parabola. For a circle, it's going to look something like 36 equals x minus 4 squared plus y plus 3 squared. And so you're going to have a number, you're going to have an x element that is squared and a y element that is squared. If you were trying to graph this on a graphing calculator, you would have to solve for y, and you would have to end up with the plus and minus case, because otherwise the graphing calculator will only draw in half a circle for you. And so you'll have to do the minus side to get the other half. So the reason I brought up the parabolas is because in this element we have this minus, x minus h, or in other words, what makes this 0 was the coordinate of a parabola. What makes these 0 is going to give us the coordinate of our center of our circle. And so the general formula for a circle says that r squared equals x minus h squared plus y minus k squared, where h and k are the center of the circle, and r is the radius. So we're going to be centered at the point hk, and will be r distance or r units away from that circle in all the directions. Some of them are very easy to graph, some of them are pretty impossible because they end up being crazy square roots, but if we draw the circle, we have the collection of all of them. So back to this original equation, what is the radius of our circle?
6.
Oh, there's a voice, hello. But yes, square root of 36, our radius equals 6. So where would the center of our circle be? Again, I don't keep track of the minus plus because it makes me crazy. I just look at it as what makes this 0. If we have negative 4, we need 4 minus 4 in order to equal 0, so our x-coordinate is 4. If we have y plus 3, you could go back to the equation and turn this into y minus negative 3, but it's a lot easier to say, oh, minus 3 is what makes that 0. So here is the center of our circle. I haven't seen anything that asks you to graph it, but understanding what's going on, that there's this center here, and the radius is a distance of 6 in all directions from that point, is useful. So, first example, very simple, says a circle in the standard xy coordinate plane has a center of 5, negative 3, and a radius of 4 units. Write the equation of the circle. Apologize if you were using the notes. They are on page 11 at the top for the equation of a circle. All right, so going over this, our radius is 4 units. In our equation, we need to have this equal to radius squared, and so you can say 4 squared, but it's most likely they will have multiplied it out to 16 for our radius. For a circle, give yourself the structure first. We're going to have x, we're going to have y, plus or minus some number, and then finally squared. So for x, the center is the x-coordinate of 5, and so we need x minus 5. For y, our center coordinate is negative 3. You can write it as minus negative 3, or you can change it to plus 3. All right. Next one, it's a little bit trickier setup. They tell you that there's a circle in the coordinate plane, and it's tangent to the x-axis at 4 and the y-axis at 4. Find the equation of the circle. I'm going to give you a little bit longer to work on this one. I'm not going to make you say anything, but go ahead and put yourself off mute when you're ready to move on so I know. Who is finished? Need a better mode of communication. Do you guys truly still need to work more on this, or do you want to move on? Okay, I'll take it. So, the first thing that you need to know in order to do this is, what does tangent mean? And that's going back to the geometry. If we have a circle, tangent means that it touches at a single point but doesn't cross through the circle. And so we are tangent at both axes, here at 4 and also here at 4. Another useful bit from geometry is that they're going to be at right angles with the radius. And so if they're at right angles with the radius, here is our center, and it's just over 4, up 4. Again, because it's tangent at this axis, which is 0, our radius distance is also 4. And so our equation is going to be that 4 squared, or 16, and it equals, again, x piece and y piece. We have a coordinate of 4, so it's x minus 4 and y minus 4. All right. So the other problem with circles that I thought was of particular interest or use again, it's using circles, but the wrinkle in it comes from understanding what circles are and using other math. So it tells us that the circle is in the standard xy coordinate plane, radius of 4 again, they really like 4. And the same center as the circle determined by x squared plus y squared minus 6y plus 4 equals 0. So again, take some time to tackle that. So they want it to have this radius and same center as this equation. So, again, I wish I had just a survey button so you guys didn't have to talk since you don't want to, but I kind of need to know, do you need a hint? Do you want to move on? Or do you need more time? That's our 3 options.
I'm fine moving. No.
Sorry, what was that?
I said I'm fine to move on.
Okay, so we have x squared, we have y squared, but we have another y. And so that is what's holding us from putting it into standard form. Otherwise, I just subtract 4 from both sides, but then we'd have a negative being the radius squared, and that would give us a whole nother set of problems. But the good news is that x squared is just x squared, and we can hold that off to the side and look at this piece. And this is going to get into completing the square territory. We're going to subtract the 4 over, so we can concentrate just on y squared minus 6y, and then plus something in order to make it a perfect square. Half of -6 is -3. -3 times -3 is going to be +9. And if we add 4 to 9, we will get 5. And so the x squared is again just x squared, but now we can factor this into, we have y minus 3 squared. And that is equal to 5, but that's not as important because they told us they want the circle with a radius of 4, but the same center as our equation. And so rather than 5, we're going to take our radius and square it and get that 16 again. I swear there's problems other than radius of 4, but apparently the book just really likes them because it showed up a lot. And so the trickiest thing about this one was knowing that you had to complete the square in order to be able to find the y-coordinate of that radius. So that was pretty much it. About half the problems I found were either giving you the equation and saying find the center, or they were giving you the radius and a center and saying write the equation. But there were a couple of them that throw in like the tangent thing is a little bit of a variety in the setup, or this one you had to complete the center or complete the square before you found the center. And so there were some slight variations using other math, but mostly it's just the idea that the x and the y give you the coordinates of the center, and the number by itself is that radius squared. Any other questions about circles, whether it came from a previous test or anything like that? Okay. I found one of my bookmarks that I missed on matrices, so I apologize for jumping around, but we're going to flip back to page 12. At the bottom of the page, the determinant is a single number that you get from a matrice. And it only is going to happen with square ones. And as far as the ACT is concerned, they're only going to ask you about the determinant of a 2 by 2. So, if they give you A is 2, 3, -1, 4, there are two different ways they might write this determinant. It looks kind of like an absolute value sign, and so they could say the determinant of A, or they might give it to you just as and not bother with the label. They just put the bracket straight lines around the matrice or the matrix number information. And so either way, they're asking for the determinant of A, they're asking for the determinant of these numbers inside. And so if you have the general case with A, B, C, and D, meaning the numbers, the equation for the determinant, again, the lines without any brackets on the top and bottom means the determinant. This is just this diagonal, A times D, minus the other diagonal, B times C. If we have the determinant of 2, 3, -1, 4, again, it's going to be this diagonal, 2 times 4, minus this diagonal, 3 times -1. And so we get 8 minus -3, and it equals +11. And so on a determinant, your answer is going to be a single number. So, final question before we are done. It asks, what is the determinant of 4, 8, 2, 5? Again, you multiply, 4 times 5 is 20, minus 2 times 8 is 16. Our determinant would equal 4. Determinants are not hard. It's a matter of, did you remember the cross multiplication, how to set it up? And if you do, great. If you don't, maybe it'll be on the test, maybe it won't, but it's good to be informed. Any last questions for me before we dismiss? The other room is already packed up, so I think they'll want me to go soon. Any questions at all? Right, you're gonna have to give me an opinion. Do you want to go, or do you want me to do a last problem that's not determinant or circle related? I just think it's interesting. Well, you're not leaving, so I guess that means do one. So, quick refresher, angle arcs, if you have a section of a circle where this is the center, this angle measure here is also this angle measure here. And if we draw in the angle to any point along the circle, that's going to be exactly half of x, or x over 2, and it doesn't matter where it's drawn. As long as my artwork works to scale, those would be the same angle. And so, this is an interesting one because they're giving us two arc measures. They're asking us to find x, but we don't have any other information. But if this is 98 degrees, then this sector, or this arc of the circle, is also 98 degrees, and this angle right here is exactly half that, or in other words, 49 degrees. If this is 104, this is going to be the exact half at 52. And then finally, whether you use the fact that this adds up to 180 to find this final angle, or you remember that exterior angle theorem that says this plus this is equal to this outside angle, you're gonna have 52 plus 49 equals 101 degrees. And so, looking through the book, I hadn't seen, I saw the arc measure, but I didn't see anything about this angle being half that, and it showed up in a couple of the different problems I thought, and so I wanted to go over this one with you so that you know that one. The one that most likely will show up, this one was a little unusual because it was such odd arcs, but frequently, if you have the diameter of a circle going through that center, anything along here, remember, a diameter is 180 degrees, this will be a 90-degree right triangle. And again, it doesn't matter where you draw that, you always have that right triangle. And so if they were feeling particularly tricky, that might show up as part of a sine cosine tangent problem, or it might show up as part of a Pythagorean theorem. So, knowing that half of this angle is equal to the angle to the sides of the circle might be helpful. So that's my tip and trick for the day. And with that, I will say goodbye. Thank you for answering a couple times. I did appreciate it.